So in the last session, right, so we have started discussing about the architecture of the Postgres, where we have seen about what is a general purpose architecture and what is a memory based architecture, right? In the memory based architecture, so basically we have divided this entire memory based architecture into two parts. One is a shared memory components and second one is a local memory areas. And we have discussed like what is shared memory areas and what are the components of it. To rewind those, so shared memory area is a memory area which is accessed by all the background process in Postgres. So, and what are the components of shared memory areas? We have clock buffers, we have shared buffers, and we have val buffers. So, what is shared buffers? So it is a RAM based memory area. So whenever client sends a request, so first it will go and check whether the requested data is available in the shared buffer or not. If the requested data is available, then we call it as a cache hit. If the requested data is not available, then we call it as a cache miss. In case of cache hit, the data will be given directly back to the client. In case of cache miss, it has to go to disk. From the disk, it has to keep the data back in the shared buffer, and from the shared buffer it has to give the result back to the client. So what is the parameter? Shared underscore buffers is the parameter to increase or decrease the size of a shared buffer, and the default value is 128 MB and the recommended value is 25% of the system RAM. And we have also discussed like shared buffer holds the dirty data. So what is dirty data? So dirty data is a data which is modified but not yet written to the disk. So who is the responsible for writing it? The background writer is a process which is responsible for writing this dirty data from shared buffer to the disk on the event of commit or checkpoint. So next component that we have discussed in the shared memory areas is val buffer. So where val buffer contains or holds the val data, so which is like metadata about the transactions that are happened in the Postgres database. So what is this purpose of val data? So val data is used for the instance recovery, and the postmaster is a process which is responsible for performing the instance recovery. So how it is going to perform the instance recovery? So whenever there is a crash for the Postgres database instance, and when you try to bring up the instance back, so first it will go and check for the latest commit or checkpoint. So why it is going to check for the latest commit or checkpoint? Because till that time the data will be written into a persistent storage. So whatever the operations that are happened between the latest commit or checkpoint to the till crash time, it has to redo the operation. If it wants to redo the operation, it has to know what are all the operations that are happened in between. So how we are going to get it? We are going to get with the help of a val data. So val writer is a process which is responsible for writing this val data from val buffer to the disk. When I say disk, it is going to write into a location called pg underscore val, and these files we call it as a val files. And val underscore buffers is a parameter, and the default value is 64 MB. So the next memory component that we have discussed is clock buffers. Do we have any specific parameter to define the size of a clock buffer? No. The Postgres is internally going to maintain the size of the clock buffers depending upon the operations, and this clock buffer holds the state of the transaction. So that state of the transaction can be in progress, committed, subcommitted, cancelled, or aborted. So and the Postgres itself is going to maintain this, and there is no DBA intervention required to maintain this memory area. So with that, so we have completed the shared memory areas. The next topic that we are going to discuss in the memory based architecture is local memory areas. Okay, so what are the local memory areas that we have in Postgres? We have a work memory. 1 minute. So what are all the local memory areas that we have? We have a work memory. We have temp buffers. We have auto vacuum work memory, and we have maintenance work memory. So these are the local memory areas that we have. Okay. So now we are going to discuss one by one. The first thing that we are going to discuss is a work memory. And the point that you need to remember is these are all the local memory areas. What is a local memory area? Each and every process will be assigned with some amount of memory which is private to the process or which is local to the process and which cannot be accessed by the other background processes. Okay. So now let's start discussing about this work memory. So I have a user or I have a client who is connected to the Postgres database. Okay, who is connected to the Postgres database and he is running some select query or he is running some queries which contains group by, order by, and join operations. Okay, so if your query contains group by, order by, or join operations, those operations are going to get performed in work memory initially. Okay, so whenever your query contains any group by or order by join operations, those operations are going to get in work memory. So work memory is going to perform the intermediate operations that we call it as. Okay, so what happens if the work memory is not enough to hold these operations? Okay, if the work memory area is not enough to hold these intermediate operations, then the operation will spill onto the disk. So what happens when the work memory is not enough to hold these intermediate operations, then the operations will spill onto the disk. How do we know whether the work memory is enough or not? As I said, if the work memory is not enough, it is going to operations are going to spill onto the disk. How do we know it is getting spilled onto the disk? How do we know, right? So let's say one session is running which is having some group by, order by, and join operations, and during that session time, if you see any .tmp files that are going to get created on the operating system level, okay, if you see any .tmp files are going to get created on the OS level, which means whatever the work memory that we have assigned, that is not enough to hold the intermediate operations. So what happens if the work memory is not enough? And or what happens if the operations are spilled onto the disk? If the operations are spilling onto the disk, so once the query is completed, again it has to accumulate everything and it has to give the result back to the client. And some of them are in memory, which is in work memory, and some of them are in the disk. So the time it takes to accumulate these operations increases. When the time it takes to accumulate the operations increases, the performance of a query might get decreases. So why it is going to get decreased? Accessing the data from the memory is faster than accessing the data from the disk. Okay, so what do we need to do when the work memory is not enough? Okay, more about this we are going to see during the performance tuning concept. But so what we are going to do, right, we are going to increase the work memory value to a some higher value. So what is the parameter to increase or decrease the work memory value? Work underscore mem is the parameter. Okay, work underscore mem is the parameter which is used to increase or decrease or maintain the work memory area, and the default value of the work memory is 4 MB. Okay, the default value is 4 MB. Okay, so and it is not recommended to increase the work memory to a higher values because it is a local memory area. Each and every session will be aligned, each and every session will be allocated with the value that is defined using work underscore mem. So it is not recommended to increase the value to a higher value because each and every active session will be assigned with the value that is defined using work underscore memory. So how can we calculate total work memory utilization? Okay, total work mem equal to number of sessions into work underscore mem value. So let's say I have a 10 active sessions. So 10 into what is the work memory value? 4 MB. Then which is like 40 MB is the total utilization. So this 40 MB will be taken from where? The system RAM. This 40 MB will be taken from the system RAM. That is the reason why we should be very careful while assigning this work memory value to a higher value. Simple. So whenever your query contains any group by or join or order by operations, those operations are going to get performed in the work memory area. If the work memory area is not enough, then it is going to operations are going to spill onto the disk. Okay, when the operation is spilling onto the disk, the time it will take to accumulate the operation increases, then the query performance decreases. And the moment you see the .tmp files, it is not recommended to increase the work memory to a higher value, because each and every session will be assigned with the value that is defined using work memory. So we should be very careful while increasing this value. So the next memory area that we are going to discuss is a temporary buffers or temp buffers. Okay, so what is the parameter is a temp underscore buffers is a parameter, and what is the default value? 8 MB is the default value. So what is the purpose of this temp buffers? In Postgres we have a concept of temporary tables. In Postgres we have a concept of what? Temporary tables. What is the purpose? What is the temporary table? In Postgres, temporary table, the lifetime of the temporary table is limited to the session. So the lifetime of the temporary table is what? Limited to session. What does it mean? So let's say you log into your Postgres database and you created a temporary table. Okay, then the moment you disconnect from the session, the temporary table will be dropped automatically. So that is the reason why I have made a statement that the lifetime of a temporary table is limited to the session. So who is going to use these temporary tables? As a DBA, we are not going to make use of these temporary tables, but developers make use of these temporary tables to store the intermediate results. Let's say a developer is going to write a procedure function and they need a table to store the intermediate data. So it can be achieved in two ways. One is he can create a normal table, he can store the data, but the end of the procedure function he needs to write an extra logic to truncate the table or delete the table, because in the next iteration again it has to store the data, right? So instead of adding that overhead, so what developers will do, right? Developers will create a temporary table in the during the procedure call or function call. It is going to store the intermediate data, and once the procedure function is completed, the table will be dropped automatically, because that is the nature of a temporary table. So as temporary table lifetime is limited to the session, once the procedure execution is completed, the temporary table will be dropped automatically. So it will be make use so it will make the developer's job easy, and because there is no additional overhead is required to truncate the table or delete the table, right? So then what is the role of the temporary buffers? Okay, if you want to perform, any operations on the temporary table, it can be a select, it can be a delete, insert or update. If you want to perform any operations on the temporary table, those are these temp underscore buffers will be used. So where this temp underscore buffers will be used? Temp buffers will be used if you want to perform any operation on the temporary tables. It can be select, insert, update, delete, truncate, anything. These operations are going to get happen in the temporary buffers. So this is about the temporary buffers in Postgres. The next one and very 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 important memory area is auto vacuum work memory. Auto vacuum work memory. So before discussing about this auto vacuum work memory, so we need to discuss about two important operations in Postgres. One is a vacuum and second one is a analyze. After getting an understanding of what is this vacuum and analyze, then we are going to discuss about this auto vacuum work memory area. And so whatever the things that I'm going to explain in today's class about the vacuum and analyze, that is purely a theoretical one. and we will be having a separate session. Okay, we will be having a separate session for the practical things related to the vacuum and analyze operations. So before discussing about this, okay, so let's talk about what is vacuum. So before discussing about this vacuum operations, we are going to see an important topic called multi-version concurrency control, MVCC. We are going to discuss about a concept called multi-version concurrency control, which talks about which user has to see what version of data. Okay, so to simplify this, any RDBMS, it can be Oracle, Postgres, DB2, MySQL, or SQL Server, any database has to be built on a basic properties called ACID. What is ACID? Atomicity, consistency, 1 minute, integrity, and durability. Okay. So these are the basic pillars on which any RDBMS will be developed on. So if you want to call any database is a relational database management system, it has to obey these ACID properties, which is atomicity, consistency, integrity, and durability. Now let's discuss about what is multi-version concurrency control. So let's say I have a table called EMP. Okay, I have a table called EMP, which contains employee number, employee name, salary, and department number. So employee number is 101, name is A, salary is 1000, and department number is 10. Now the employee number is 102, employee name is B, salary is 2000, and department number is 20. Okay, now employee number is 103, department name is C, salary is 4000, and department number is 30. Okay, so now, so this is the Postgres database, let's say. So I have a user H1. Okay, I have a user H1 who connected to the database at 9 a.m. Okay, at 9 a.m. the user is connected to the database and he performed a query called select star from EMP. So let's take an example that select star from EMP will take 30 minutes to complete the data. So at what time the user is going to get the data? At what time the user H1 is going to get the result or response? At 9:30. Okay, 9:30 a.m. user U1 is going to get the, or user H1 is going to get the response. So what is the query execution time for select star from EMP? 30 minutes. Okay, at 9:15. Okay, at 9:15 there is another user called H2. Okay, there is another user called H2 who connected to the database and he performed some update operation. What is this update operation? Update EMP set sal equal to sal plus 3000, where department number equal to 20. Okay, so the employees whoever belongs to department number 20, their salary is going to get increased by how much? 3000. So let's say within 5 minutes the update query is going to get completed. So by 9:20 update query is going to get completed. Okay, so by 9:20 the update query is going to get completed. So according to the ACID properties of the database, user H1, okay, user H1 should get the data as of 9 a.m. So whatever the data, what is the data at 9 a.m.? This is the data at 9 a.m., right? So according to the ACID properties of the database, user H1 or session H1 should get the data as of 9 a.m., which means whatever the data that is there in the EMP table at 9 a.m., H1 should get only that data. So whatever the intermediate update operations or modifications that are happened in the EMP table, those should not be visible to the H1 user. So because the user H1 has started a query at 9 a.m. So whatever the data that is present in the EMP table at 9 a.m., that data only should be visible to the user called H1. So whatever the intermediate that operation that are happened, those should not be visible. So to maintain this, Postgres, this we call it as a multi-version concurrency control, and this multi-version concurrency control in Postgres is achieved using a concept of dead tuple. Okay, so what does it mean by dead tuple? That we are going to see it in a while. Before discussing that, the how the EMP table will be rewritten, right? So how the EMP table is rewritten. So let me give you the EMP table at 9 a.m. So at 9 a.m. the EMP table is, so at 9 a.m. what is the EMP table that we have? So we have 101, 102, 103. A, B, C, 1000, 2000, 4000, 10, 20. That is, this is the data that we have at 9 a.m. So after 9:20, this table will be modified as, okay, how this table will be modified, after 9:20 what happened, there is an update operation that happened, but according to the multi-version concurrency control, user H1 who started his query at 9 a.m. should get the data as of 9 a.m. So this table will be rewritten like, so do we have any changes for 101? No. 101A 1000 and department number is 10. Now observe it carefully. For the department number 20, what is the update operation? Update EMP set sal equal to sal plus 3000, where department number equal to 20. So this row will be written as 102 B 2000 plus 3000, 5000, department number is 20. And observe it carefully. Again 102 B 2020 and 103 C 4030. Okay, so if you see, whenever you, so this data, this is the old data, right? 102B 2020 is a old data, and this data we call it as a dead tuple. So what is dead tuple, right? Technically, whenever you perform any update operation in Postgres, it is nothing but a insert plus delete. Okay, technically, whenever you perform any update operation in Postgres, it is nothing but a insert plus delete, where a new row will be inserted with the updated value and old row is marked as a dead. So how can we define dead tuple? Technically in Postgres, update operation is nothing but an insert plus delete, where a new row will be inserted with the updated value and old row will be marked as a dead. So, and who needs this dead tuple? The session who started at 9 a.m. Okay, the session who started at 9 a.m. he needs a dead tuple, because dead tuple contains the old data or before updated data. So until what time this dead tuple is needed? Till 9:30 this dead tuple is needed. Once this session, the user H1 or session H1 got the data, got the result, do we need to maintain this dead tuple? it is not required. So why do then what is, how can we remove? So how can we remove, right? Vacuum is an operation. Okay, vacuum is an operation to remove what? Vacuum is an operation to remove dead tuples. Okay, vacuum is an operation to remove dead tuples. Why do we need to remove dead tuples? If you are not going to remove the dead tuple, then the time it will take to scan the table increases. When the time it will take to scan the table increases, the performance of a query might get decreases. So what is vacuum? Vacuum is an operation to remove the dead tuple. Then what is dead tuple? In Postgres, multi-version concurrency control is achieved using a concept of dead tuples. So whenever you perform any update operation in Postgres, technically it is nothing but an insert plus delete, where a new row will be inserted with the updated value and old row is marked as a dead, and vacuum is an operation to remove the dead tuples. So let's take an example, okay? Let's say at H1 started at 9 a.m. and the completion time is 9:30, and before that one someone has performed an update operation. And what happens if you perform vacuum operation at 9:25? What happens if you perform vacuum operation at 9:25? So what vacuum is going to do? Vacuum is going to remove the dead tuples. Vacuum is going to remove the dead tuples. And if you perform the vacuum operation at 9:25, does it going to remove the dead tuples? No. Why it is not going to remove the dead tuples? Why it is not going to remove the dead tuples is because that dead tuple is still needed by the session. This dead tuple is still needed by the session H1. Till when it needed? Till 9:30 it is needed. That is the reason why, though if you perform, okay, though if you perform any vacuum operation in between, the vacuum operation will be successful, but it is not going to remove the dead tuple, because this dead tuple is still needed by whom? This dead tuple is still needed by the session who started that session at 9 a.m. So the operation will be successful, but you will not get the vacuum operation is successful, but it is not going to remove the dead tuples, because these dead tuples are still needed by the long running transaction. So what is vacuum? Vacuum is an operation to remove the dead tuples. Any doubts so far, or can I continue?
Yeah, hello.
Yeah,
You mentioned dead triple. So, can you explain that particular row to when we insert the row? The dead triple mean when you
yeah, yeah,
perform a Postgres, technically it means inserting the row, right?
yeah. Yes.
Yeah.
See, if you see,
Can you repeat that particular?
yeah. So
Yeah.
whenever you perform any update operation, it is nothing but an insert plus delete, which means a new row will be inserted with the updated value. What is the updated value? What is the before update? What is the salary of employee B? 2000. After the update, what is the salary of this employee? 5000. So a new row will be inserted with the updated value, and old row is marked as a dead. So if you see the old row is having a 2000 as a old value. And who needs this old row? The session who started at 9 a.m. that needs this old row. Until when it is needed? Till 9, in our example, till 9:30 this dead row is needed. After 9:30, do we need to maintain this dead tuple? No. So how can we remove?
No, it
Through vacuuming, you can
through
remove this
vacuum.
dead tuple. Is this clear now?
Okay, got it, got it. Thank you.
Yeah. So that's how the vacuum operation will be helpful to remove the dead tuples from the system. And one more point that you need to remember is, let's say if you are going to run a vacuum operation, but this dead tuple is still needed by the system, then your operation will be successful, but it will not remove the dead tuples, because these dead tuples will be needed by the some long running transactions in the database. So with this thing in mind, I'm going to explain one more so with this thing in mind, I'm going to explain one more operation in Postgres, which is analyze. Okay, which is a analyze. What is analyze? Analyze is nothing but gathering the statistics in the of the database, gathering the stats. So why do we need to gather the stats? Let's say I have a EMP table. Okay, let's say I have a EMP table, and so whenever you are running any query on this table, it is taking more time to complete. So what is the next step that you are going to do? We recommend to create an index on the columns that are being used in the where clause or join condition, right? So let's say we have created an index on the EMP table, but we should let the optimizer know that we have created an index on the EMP table. How the optimizer knows? So why optimizer needs to know about the changes in the tables? Because optimizer is the one who is going to create some execution plans based on the table statistics. So what is the way to let the optimizer know about the index creation? By gathering the statistics on a table. So how can we gather the statistics on a table? Using a analyze command. Analyze is an operation to gather the stats on a table, so that optimizer is going to create a better execution plans depending upon the statistics. So what is the analyze? Analyze is going to gather the statistics on a table. So we can gather the stats on a table, or we can gather the statistics on a entire database, which we are going to see it in a while. Okay, so this is about the vacuum and analyze operations. So whatever the discussion that we have gone through so far, so we have discussed about what? Vacuuming, and we have discussed about the analyze. So how we are going to do? We are going to do this operation manually. So let's say I have 100 tables on the database. Every time you can't go and run the vacuum operation, right? And every time you cannot go and run the analyze operation as well. So so what is there, right? So to avoid the manual intervention of running the vacuum, okay, to avoid the manual intervention of running the vacuum and analyze operations, okay, to run the vacuum and analyze operations, Postgres has introduced a concept or feature called auto vacuuming. Postgres has introduced a concept called auto vacuum. What is auto vacuum? Auto vacuum is a feature. Okay, auto vacuum is a feature in Postgres. With help of this auto vacuuming, Postgres has automated the vacuum and analyze operations. Okay, so auto vacuum is a feature in Postgres. With help of this, Postgres has automated the concept of vacuum and analyze. So auto vacuum contains how many operations? Auto vacuum contains two operations. One is auto vacuum and second one is auto analyze. If you run the vacuum operation manually, okay, if you run the vacuum operation manually, then we call it as a vacuum. If you run the analyze operation manually, then we call it as a analyze. If the system runs the vacuum operation, then we call it as a auto vacuum. If the system runs the analyze operation, then we call it as a auto analyze. So the same vacuum and analyze operations are automated in Postgres by using a concept of auto vacuuming. And this auto vacuuming contains two operations. One is a auto vacuum and second one is a auto analyze. So before discussing about how the auto vacuum works and auto analyze works, so we are going to see how can we perform the normal vacuum and normal analyze operations. So let's say I have a table called EMP, and this table is available in a schema called SCH1. What is schema? That we will be seeing it once the installation is done. So if you want to run vacuum operation on the table, how can we run? So vacuum, okay, vacuum space schema name dot table name. When you run this, vacuum operation will be triggered on the table. So how can we, so as I said, the vacuum operation can be run on a particular table, or vacuum operation can be run on a entire database level. So if you want to run a vacuum operation at a database level, then just you need to connect to a database on which you want to run the vacuum operation. Let's say I have a database called db1, and that I am planning to run the vacuum operation. Just connect to the database on which you want to run the vacuum operation and simply execute like vacuum. So this will run the vacuum operation on the database level. More about this we are going to see it in the later classes. We will be having one practical session on the vacuum and analyze and auto vacuum and auto analyze operations. Okay, so this is how you can run the vacuum operation at a table level, and you can run the vacuum operation at a database level. So if you want to display the progress of the vacuum, then you can use a operation called verbose. Vacuum verbose schema name dot table name. Vacuum verbose schema name dot table name. So if you want to run the same vacuum operation at database level, just you can do vacuum space verbose, then it will run the vacuum operation at a database level, but and it will show you the progress. Okay, and so how can we run the analyze? Similar to vacuum, we can run the analyze operation on analyze space. Just remember this, it's not required because we will be having a one more session on the same. So analyze schema name dot table name. If you want to run the at database level, then analyze, just come to the database on which you want to run the analyze, and you can run the analyze. If you want to print the progress, again you can use a verbose option again. And so we can combine both these vacuum and analyze operations in a single command. How can we do? Vacuum verbose analyze. Vacuum verbose analyze schema name dot table name will run the vacuum operation. Once the vacuum is done, it is going to gather the statistics using analyze command. And so this is how you can run the vacuum and analyze operations on a particular table or particular database. Now, so as I said, when you run the vacuum and analyze operations, then we call it as a vacuum and analyze. If the system is going to run the vacuum operations, then we call it as a auto vacuum. And if the system is going to run the vacuum operation, then we call it as the auto vacuum. If the system is going to run the analyze operation, then we call it as a auto analyze. So when the system is going to run the vacuum operation automatically, because every time it can't go and run the vacuum operations on all the tables, right? So there should be a criteria. Okay, there must be a criteria. So whenever that table reaches that particular threshold, then the system is going to run the auto vacuum and auto analyze operations. So how can we calculate? For to calculate that, we have a formula. So auto vacuum vacuum threshold, auto vacuum threshold for table equal to auto vacuum threshold for a table equal to number of rows into auto vacuum scale factor, number of rows into auto vacuum scale factor, number of rows into auto vacuum scale factor plus auto vacuum. No need to worry about all those things. I will be providing you a document. Okay. Auto vacuum threshold. This is the formula. So number of rows means total number of rows particular table is having. Let's say I have a table called EMP which is contain 1000 rows. Then let's try when the vacuum operation will be triggered on the EMP table. Okay, number of rows is 1000. Then auto vacuum scale factor is a parameter. So what is parameter? That we will be seeing it in the post installation. We will be having a concept of parameter file management where you will see what is parameter and how can we change it. Okay, auto vacuum scale factor is a parameter and the value of this parameter is 0.2 plus auto vacuum threshold also a parameter, the value is 50. So now 1000 into 0.2 plus 50, which is like 200 plus 50, which is like 250. Whenever there are 250 dead tuples on the table, whenever there are 250 dead tuples on the table, then the system is going to run the auto vacuum operation on the table automatically. Okay, whenever there are 250 number of dead tuples that are there in the table, then the system is going to launch the auto vacuum operation on the table. So then when the analyze will be happen, simple auto vacuum analyze threshold, auto vacuum analyze threshold for a table equal to number of rows into auto vacuum analyze scale factor and auto vacuum analyze threshold. So here 1000 into the value of auto vacuum analyze scale factor is 0.1 plus 50, which is like 150. Whenever there are 150 number of rows that are inserted on the table, okay, then the auto analyze operation will be triggered automatically. Those things will be seeing it in a practical in the later classes. So that's how whenever a table reaches the auto vacuum threshold or whenever a table reaches the analyze threshold, the system is going to run the auto vacuum and auto analyze operations automatically. How can we check when the auto vacuum and when the auto analyze operations are happened on a particular table? We can check using a data dictionary called pg underscore stat underscore all underscore tables. PG underscore stat underscore all underscore tables is a data dictionary which contains the information about when the table was last auto vacuumed and when the table was last auto analyzed and how many dead tuples the table is having. Okay, so this is the information about this auto vacuum and auto analyze operations in Postgres. So do you have any questions so far? Do you have any questions so far? If not, then I'll continue.
Yeah, continue, please.
Yeah. So now you got an idea about what is vacuuming, what is analyze, what is auto vacuum, and what is auto analyze. Now with the knowledge in mind, I'm going to introduce the memory area called auto vacuum work memory. Auto vacuum work memory. So we discussed about this auto vacuum and auto analyze operations. Who is responsible for performing this auto vacuum and auto analyze operations? Are there is a process called auto vacuum worker. Auto vacuum worker. Auto vacuum worker is a process which is responsible for performing this auto vacuum and auto analyze operations. So each auto vacuum worker will be assigned. Okay, each auto vacuum worker will be assigned with a memory that is defined using auto vacuum work memory. Auto underscore vacuum underscore work underscore mem. So each auto vacuum worker will be assigned with a memory that is defined using auto underscore vacuum underscore work memory to perform this auto vacuum and auto analyze operations. So now what is the auto vacuum work memory? Auto vacuum worker in Postgres, auto vacuum worker is a process which is responsible for performing the auto vacuum and auto analyze operations. So each auto vacuum worker will be assigned with a value that is defined using auto vacuum work memory to perform this auto vacuum and auto analyze operations. So how many auto vacuum workers will be created? How many auto vacuum workers will be created is depending upon a parameter called auto vacuum underscore max underscore workers. Auto vacuum underscore max underscore workers is a parameter. Depending upon this parameter, auto vacuum worker number of auto vacuum workers will be created. Now by default there are 3 auto vacuum workers, so each auto vacuum worker will be assigned with a value that is defined using auto vacuum work memory to perform auto vacuum and auto analyze operation. So what is the value of the auto vacuum work memory? The default value of the auto vacuum work memory is -1. Why it is -1? That you will be getting it in a while. So what is the parameter? Auto vacuum underscore work underscore mem and the default value is -1. So why it is -1? That we will be seeing it in a while. So the next memory component that we are going to discuss is a maintenance work memory. Maintenance Okay. The next memory component that we are going to discuss is a maintenance work memory. What is this maintenance work memory is? So in Postgres, we are having some maintenance operations. We are having some maintenance of, what are the maintenance operations that we have? We have a maintenance operation called create index, a normal vacuum. So normal vacuum means if you run the vacuum operation, and analyze, altering a table. Okay, so we have a create index, vacuum, analyze, altering a table, and creating a foreign key. Okay, creating a foreign key. These are all the maintenance operations that we have in Postgres. Okay, whenever you run any of these maintenance operations, those operations are going to get happen in which memory area? Maintenance work memory area. Okay, so maintenance work memory is a memory area which is used for performing the, which is used for the which is used for performing what? Which is used for performing the maintenance operations. What are all the maintenance operations that we have in Postgres? The maintenance operations that we have in Postgres is create index, vacuum analyze, altering a table, and creating a foreign key. So these are all the maintenance operations. Whenever you wanted to perform any maintenance operations, those operations are going to happen in the maintenance work memory. And okay, those are going to happen in the maintenance work memory. And so what is the parameter related to maintenance work memory? Maintenance underscore work underscore mem. Maintenance underscore work underscore mem is a parameter, and the default value is 1 GB, right? So let's say if you get a request for creating an index, or if someone raises a request for performing the vacuum operation or analyze operation, as a DBA, your focus should be always like how, okay, how fastly we can create an index, or how fastly we can complete the vacuum operation and analyze operation. So as a DBA, whenever you get a request, okay, as a DBA, whenever you get a request for creating an index or vacuum or analyze operations or altering a table operations, you can increase this maintenance work memory at session level, and you can perform the operations. So how can we increase a, how can we set the parameter at a session level? That will be seeing it in a parameter file management. So whenever you change any value of a parameter at session level, then the value is limited to the session only. Once the session is disconnected, okay, once the session is disconnected, it is going to redefine to a value that is defined using in the parameter file. Okay, that's how a maintenance work memory will be used. So now in the previous class, in the previous thing, so what we have discussed, what is the value of auto vacuum work memory? The value of the auto vacuum work memory is a -1. So why it is -1, right? So there is a relationship between maintenance work memory and auto vacuum work memory. Okay, if auto vacuum work memory is -1, if auto vacuum work memory equal to -1, then each auto vacuum worker, okay, if the auto vacuum work memory is a -1, then each auto vacuum worker will be assigned with the value that is defined using maintenance underscore work underscore mem. So what is the relationship between auto vacuum work memory and maintenance work memory? If the auto vacuum work memory value is -1, then each auto vacuum worker will be assigned with the value. Okay, then each auto vacuum worker will be assigned with the value that is defined using maintenance underscore work underscore memory. So that is the reason why, though if the auto vacuum work memory value is -1, we will be able to perform the auto vacuum and auto analyze operations. Okay, is this clear, or do you have any doubts so far? Okay, Hope it is clear. So with this, we have completed the memory-based architecture in Postgres. In the next class, we are going to see the process-based architecture in Postgres, and from Tuesday onwards, we will be entering into the installation of the Postgres, and we'll be going to see how can we manage the Postgres databases, how can we do a parameter file management, schema management, database management, table space management, and users and privilege management, backups, recovery, and replication. So we will be having a one more theoretical session. Okay, once that is done, we will be entering into the concept of actual Postgres administration. But understanding the Postgres architecture is very important to troubleshoot the issues. Okay, if you don't have any doubts, that's it for today, and we will connect tomorrow again. Thank you.